Now we've got a new topic today, and one that you probably weren't expecting. We're reaching the end of the course, actually. This topic, time and space, will occupy us today and most of Tuesday, and then we've got one topic left, which is consciousness. There'll be no lecture on the coming Thursday. You won't get an email to that effect. Now, when we're doing cognitive science, as much as we might like to do our straightforward science, we're never far from philosophical issues. There's just nothing you can do about that. The nature of cognitive science is to ask questions about the relationship between the world and something that knows the world, a subject, a knowing subject. And that is challenging for any kind of science. The philosophical questions associated with knowing are very, very, very old. And today we're going to encounter one of the oldest, most profound philosophical questions that has ever been debated, and its relation to cognitive science. You're all aware of the fact that the world seems to be full of stuff. Desks, people, lunches, concerts. And all that stuff seems to be contained within time and space. Now, there's an old view in physics, going back to Isaac Newton, which is exactly that time and space are containers. And what science correctly addresses is the movement of things within those containers. Unfortunately, that view went out the window in 1905 with the theory of special relativity. And since then, physics has gone strange ways, to the extent that modern physics bears very little relation, or no relation, to the world of everyday experience. The theories in modern physics look for their evidence in extremely erudite kinds of recordings taken from space, taken from complicated machines, but not from the everyday world of time and space. The old Newtonian physical view that had time and space just as containers makes sense to us as embodied living beings because we have this sense of living through time and space. Of these two, space seems to a living being to be somehow maybe a bit simpler. You can move around in space, you can explore space with your hands, you can dance around in space. You're kind of restricted to living with the passage of time, living eternally in the now. If I ask you what time is it, you could justifiably say it's now. And I'll do it again and you'll say it's now. And we can do this all day. It'll always be now. That's the right answer. It's just not a very informative answer. The view of time as being now is available to living beings, conscious, sentient beings. I don't know if rocks have any sense of now. Interestingly, physics has no theory of the now. Einstein himself despaired of coming up with, of grounding our sense of the familiar now in a physical theory. So we're stuck with this fact. In Einstein's theory, time and space are conjoined. Time is an extra dimension of space. It has some properties that distinguish it from three spatial dimensions, but they don't include the notion of now. For us, our encounter with space is direct, playful, simpler in some respects than our encounter with time, which is deeply mysterious. You're all aware that time is passing, but you don't have an organ that senses time. You don't have a chronometer in you that measures the passage of time. All of our sensory modalities are concerned with stuff that changes in time. So vision is based on the changing patterns of light and dark on the retina. Your sense of touch is based on changing patterns of stimulation on the skin. All perception is based on change. Something which is constant is not perceived. I'm sure many of you have had the experience of you're sitting in a room, and then the air conditioner switches off, and you go, oh my God, I'm just hearing that air conditioner now. And there you are hearing it, and it's gone. Right? The air conditioner is not there, and you're hearing it for the first time because it was constant, 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 and what you noticed was the change. This is kind of paradoxical. So thinking about our relationship to time and how we are embedded in time and in space has a long history. We can go back to Aristotle. I know it's not very surprising. We go back to Aristotle again and again. And Aristotle addressed the subject in his book on physics, called Physics. He said, time does not exist without changes. Good man, Aristotle. That's pretty much what I was just saying. And I think Aristotle's observation is probably the best that has been made on the subject. But that doesn't stop us teasing this out a little bit. And as usual in cognitive science, we'll encounter some very different approaches to the same topic. You're familiar at this stage with the contrast between empiricists' concerns with lived experience and sensory motor embedding in the world, and rationalists' concerns with reason. Well, David Hume is the best of the empiricists, a Scotsman. He was considering what time is and how we become aware of the passage of time. And he said this, he said, a man in a sound sleep or strongly occupied with one thought is insensible of time. When we have no successive perceptions, we have no notion of time. He says time cannot make its appearance to the mind, either alone or attended with a steady, unchangeable object, that's that air conditioner, but is always discovered by some perceivable succession of changeable objects. So Hume, being an empiricist, is looking out at the world and looking and seeing, he's perceiving change. He sees that leaves fall off trees, that air conditioners stop. He didn't have air conditioners. But he's observing change in the world, and this is how Hume thinks we come to know the passage of time. Now we're going to contrast that with, as usual, with Descartes. Descartes, of course, our preeminent rationalist, retreating from his senses, adopting a skeptical position, trying to solve everything with reason, and looking, as it were, within himself, whatever that means. Descartes says, when I think that I am now, and also remember having been in the past, and I conceive several different thoughts whose number I know, I acquire within me ideas of duration and of number. We forget the number bit for the moment, we're not concerned with that. His ideas of duration, this is Descartes becoming aware of the passage of time because he believes he persists as the cogito, as this psychological unity that has a past. The past has gone and is forever fixed, and the future is still to come. And so it's change within him, within his own being, that Descartes grounds his sense of time with. So the empiricist looks out and observes changes in the external world. The rationalist introspects and observes change, as it were, within one's own mind, whatever that means. I'm not sure there's much of an improvement there on Aristotle, who said, look, it's change. That's about right. You can see that this is going to pose some deep problems. And one of the best things that comes about ruminating on our relation to space and to time is to recognize that we live at a particular spatial scale and we encounter change at a particular time scale. This might seem less than obvious to you. You might think that the world is simply there and that galaxies are big and ants are small, and a second is a very brief period of time and a 1,000 years is a long period of time. Any of those observations only make sense by comparison with some standard, and the standard is given by your body and your experience of time. There is no objective sense in which the sun is big. It's big only by comparison with something. It's not big by comparison with a galaxy. It's big by comparison with you. An ant is only small by comparison with you. To an atom, an ant is a very large proposition. So that the whole notion of big and small comes from a center, and that center is provided by your body and your experience of space. If you were an ant climbing a blade of grass, well, you don't go around climbing blades of grass, most of you, do you? Because you can't. But an ant can climb a blade of grass. The world is different to an ant. A raindrop is an existential threat to an ant, and also a potentially rich source of drinking water, but if you burst it, you get drowned. You don't experience raindrops like that. A paramecium down there probably doesn't even have a sense of three-dimensional space. I don't know what this rather rude English giant is, how he perceives space, but imagine 7-league boots and striding around much bigger than you are. How does a sperm whale perceive space? This is an animal impossibly big, living in a medium like water, whose encounter with space is going to be completely different from yours. And so the world that arises for these animals is going to be different than that which arises for you. Now, if that's true of space, it's also true of time. We're less aware of this. When something is too small to be perceived, we magnify it. We use magnifying glasses and microscopes to bring it into the realm of which we can perceive things. If something is too big, like the cosmos, we reduce it to make it perceptible. If it's too distant, we use telescopes to bring it into the realm where we can perceive things. We do that optically. We do it with time as well. We do it with high-speed photography, and we do it with time-lapse photography. What these do is they change the passage of time, speeding it up or slowing it down, and make things perceptible to us that are perfectly real. You know, crystals, tiny little crystals, giant galaxies, those are perfectly real as well. The splash, the event of a drop splashing into a liquid like that is perfectly real. It just happens too fast for us normally to see. The event of the unfolding of the cactus flower is perfectly real, but it's not normally perceptible by us. We have to speed that one up and slow that one down in order to see them. This is the temporal equivalent of a magnifying glass or a telescope. And with that, we have to recognize that we encounter the world at a particular spatial scale and at a particular temporal scale. There are animals whose experience of time will be completely different from ours. A mayfly that only lives a day and has to get all its business done in one day. A cicada that lives 16 and a half years underground, waiting for that brief burst when it'll come out, have sex, eat, and die. That's what life basically is. Animals encounter time very differently depending on their constitution. And they encounter space very differently depending on their constitution. And that leads me to my main quibble today, which is with the quality of our space aliens. When you see this kind of thing paraded around as a space alien, nobody has even begun to use their imagination. This is nothing but a dressed up human. It's got bilateral symmetry, a head, 2 eyes, arms, legs. It's just a human with a slight variation. Nobody has even considered what it is to be something other than a human. This is human in every possible sense. I've been using this to complain about the paucity of our imagination about space aliens for many years, and I was delighted last year to see The Onion, a fine satirical magazine, getting in on the act with this article saying scientists speculate that extraterrestrials may have completely different hair than humans. That's about as good as our space aliens are. If you want to really consider what another form of life would be, you have to first of all recognize what yours is and realize that you live at a particular time and spatial scale that influences the world that you encounter. That's kind of useful and it's fun. Now let's come back to this business of the now. What time is it now? What time is it now? What time is it now? We live constantly in the now, but we live with this conviction that the past has gone and can't be changed, and the future is yet to come and is uncertain. I hope you all subscribe to that belief, because if you didn't, it'd be a bit odd in our society. But the evidence for this is rather scant. If you look around you in the present, you're always in the present. And here's the conundrum. The present is an infinitesimal. It has no duration whatsoever. It's this dimensionless point at which the future rushes into the past. But for us, there's a huge distinction between the future and the past. And the present doesn't even feature here. It's an infinitesimal. It has no dimension whatsoever. So this view of time as linear, as extending from past to the future, needs to be reconciled somehow with this view of life as lived in the present moment. And I can tell you with a certain degree of confidence that neither scientists nor philosophers have gotten a handle on this problem yet. It's a deep, big, rich problem, possibly the best one that we've ever found, and we've got nowhere towards solving it. I'm not sure there is a solution. I think the problem is going to change us rather than us mastering the problem. It hasn't escaped attention though. Starting with Aristotle, we've looked at some philosophers. William James was one of the first early psychologists, and he started thinking about this, the weird way that our understanding of time, expressed like this, doesn't match our experience of time, which is of a present. And he came up with a notion called the psychological present, which is a kind of a good guess. So he noticed that we experience change in 2 different ways. One way clearly involves memory. So supposing the lights here were to go down very, 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 very imperceptibly slowly, sooner or later someone would go, hey, look, it's got dark around here. Not because of any immediate change, but because you remember that it was light. And contrast that with your experience of a bell ringing. Ding-a-ling-a-ling-a-ling-a-ling-a-ling-a-ling-a-ling-a-ling. You're not reaching into your memory there. You don't have to. You're experiencing it in the present. So the idea is that some change is registered within some small time window called the psychological present. There it is illustrated. How big is it? Well, this concept is not sufficiently well grounded that we can say that. If you're confused about this notion, think of this. Imagine you're sitting looking at a clock. You know the hour hand is moving and you know the second hand is moving. How do you experience the movement of the hour hand? Well, when you look at it, it doesn't seem to move, but now it's at 3 and later it'll be at 4 and you go, yeah, it must have moved. I remember it moving. I remember it being in a different position, so I figured out that it moved. Now contrast your knowledge of the movement of the hour hand with your knowledge of the movement of the second hand. You see the second hand move. That's what we mean by seeing. It's in the psychological present. You observe it directly. You don't have to reach in and remember that the second hand was somewhere else. So that distinction between the way that you know how the hour hand has moved and the way that you know how the second hand has moved, that serves to illustrate this notion of the psychological present. The psychological present, if you take it literally, has a weird consequence, which is that you're living in the past. Huh? Well, if you think that your experience of the present comes through your senses, the light patterns of light and dark on your retina, and then messages sent to your brain, and so on, well, whatever, by the time your brain is able to register something, it's already happened in the world. Deep, deep problems. They've been around for a long time. That distinction about the way that you see the hour hand and the way that you see the second hand move was first observed by Broad there back in 1923. So we've encountered a lot of mystery already. My God, we're 20 minutes into the lecture and we're halfway down the rabbit hole. We're going to keep going. How do we think about time? What we're going to do is we're going to look at some science in the area that's not going to solve these big philosophical problems, but it's going to add fuel to them. It's going to give us some more to think about. There is science you can do in this area, and some of it is quite counterintuitive, and some of it is quite surprising. And we're going to look in particular at a small body of scientific work that asked, how do people regularly understand time? Not what is time, we leave that for the philosophers, but how do people understand and think about time? And to do that, we have to reach back, we have to go back to the 1940s and an old notion in linguistics of all things, something called the Sopir-Whorf Hypothesis. The Sapir and Whorf were two linguists who were interested in the way that the language that you speak provides you with the categories with which you understand the world. They formulated a hypothesis, became known as the Sopir-Whorf Hypothesis, which was that the language that you speak determines how you see the world. This is a very strong notion, and we have available to us a weaker version of it, which is that the language that you speak affects how you think the world. And let's consider those two separately. The strong version says that literally you learn one language and so you're going to understand the world in terms of the categories that you got from that language. And on that view, I think translation from one language to the other is impossible. That's moving from one conceptual scheme to another conceptual scheme. Language on that view is not a set of labels applied to the world, it's a means of understanding the world. Now, nobody is really happy with this. It gave rise to a great deal of mythologizing, among other things, about all the words that Eskimos have for snow. Some of you may have encountered that discussion. The fact is, yes, Eskimos have lots of words for snow. So would you if you had lots of snow. We Irish have lots of words for rain. The weak version has generated recently a lot more scientific work. The idea that the language that you speak affects how you think the world. And we're going to give that a separate name now. We're going to call it the linguistic relativity hypothesis. Consider, if you will, color labels. Now, you remember we met categorization and we noticed that when we enter a domain, we talk about a domain like furniture. There's a certain level at which we have basic categories, things that are easy to visualize, like table is a basic level category in the domain of furniture. Furniture itself is too abstract, and Victorian dressing table is too concrete. Table and chair, these are basic level categories. Well, let's look at the domain of colour. In the domain of colour, as English speakers, red, green, blue, and yellow are basic level categories. Of course, there's a superordinate category of colour itself, which you can't visualize because it has to be one colour or another. And we can further subdivide those. So red is a basic level category, but we can distinguish between vermilion and scarlet, for example, and ruby. But red, for English speakers, serves as a basic level category. For Russian speakers, blue does not serve as a basic level category. Blue is two basic level categories. Back when there were monolingual Irish speakers and monolingual Welsh speakers, gloss refers to a blue-green category. There was one basic level category which encompassed blue and green, something still found in many languages of the world. So that the basic level categories are tied to the language that you speak. That's the kind of thing that we explore when we ask about linguistic relativity. Now, I'm not going to spend a lot of time on the strong version of the Sopir-Whorf hypothesis. It has influenced a lot of thought, but it's basically been rejected. I have a slide here which you can read on your own time, which outlines it. But we're going to simply recognize that on the strong version of this hypothesis, language determines how you think. So language is the means by which you access the world and the means by which you think. Translation would be impossible, and nobody really believes that anymore. But we believe, or are exploring in a scientific sense, something closely related, which is the linguistic relativity hypothesis, the idea that language influences how we think about such things as colours. And well, what we're going to explore here is how language influences how we think about time. The idea being that language processes interact with the fundamental operations of thought. We've met this before here several times. You all remember our sentence about robbing orchards, which had a complexity to that thought that was not expressible without language. Well, we're exploring this now a little bit longer, a little bit more directly. We're exploring the weak version of the hypothesis and not the strong version. And this work comes from a psychologist from Stanford University called Lera Boroditsky, and initially it was done in conjunction with someone called Michael Ramskar, and it's been going on now for about 15 years. The question is, how do we think and reason about things that we've no sensory experience of? If we adopt an empiricist position that we come to know the world by sensing and experiencing it, and we've no direct experience of something as abstract as time, how do we come to reason and think about it? Well, the suggestion that Boroditsky is following, I'm not sure I buy it, but I think it's an interesting way to think about things, is that our reasoning about time, which is a very abstract domain, is built on, and parasitic on, as it were, our reasoning about space. So space, we can explore space directly. We can reach out, move around, we can wander around. We're not confined to one space. We're free to explore the notion of space in a way that we're not free to explore the notion of time. You can't zip forwards and backwards in time. Sorry, that's not going to be possible. And her suggestion is that, well, in this way, reasoning about the abstract domain, time, must be grounded in something more concrete. And she suggests it's grounded in something, in how we reason about space. And a lot of this work makes clever use of a single question, which is posed to people, and the responses are recorded, and that's the whole of the experiment. And we're going to do it with you right now. I'm going to want you to make your mind up about this very quickly, and don't change your mind. All willing? Okay. You have a meeting on Wednesday. Wednesday's meeting has been moved forward 2 days. Which day is it on? You've made up your mind. Hands up for Monday. Hands up for Friday. Were you aware that there were two answers? In general, about half people say Monday and half people say Friday. This question is carefully constructed to be ambiguous. In the class I just taught, it was literally a 50-50 split. Here there's a greater proportion of people go for Friday. That's bizarre. How can there be two answers to the same question and you're not even aware that there are? Well, Boroditsky's way of understanding this, the way that she lays it out, says that there are two metaphors you have, two metaphors that come from space, spatial reasoning, that you can apply to time, and that some of you are applying one and some of you are applying the other, and you're not aware of the fact. The two metaphors, brace yourself for some world-class artwork, no expense spared. The two metaphors are illustrated here. The top one represents an ego-moving perspective, which I will now demonstrate. Here I am, striding boldly forward through time, leaving my past behind towards a future of unlimited possibilities. That's me striding forward. There's my meeting on Wednesday. It's moved forward, so I'm going to say Friday. See, my movement defines forward, so forward is later in time. Now let's contrast this with this, I said time moving, you can also call it the couch potato metaphor. You're sitting there, you're looking, thinking about the future, and you're going, oh Jesus, that exam is coming like a freight train. The exam is coming towards me. So things in the future are coming towards you. Well, there's Wednesday meeting. Forward means closer to me, means Monday. So depending on whether you were thinking in this framework or this framework, you would answer that question differently. You would answer Monday or you would answer Friday. Friday, if you're more engaged and moving forward yourself, and Monday, if you're kind of stuck. How do you test something like this? Is this plausible? Well, this is kind of neat work. Here's the lunch queue at Stanford, in the psychology department. Same place we had the Stanford Prison Experiment. We got over all that. Here we are having lunch, and it's about 50 meters long, and it takes about 10 minutes to get your sandwich. And what they did was they went out and you asked people at various points along the queue this Wednesday forward question, and you just register their responses. And it turns out the answer that they give you depends on where they are in the queue. Who knew? It's kind of bizarre, isn't it? So remember, if you're moving forward, ego moving is Friday. If you're the couch potato, things are coming at you, it's Monday. Well, over on the left-hand side, the white bar, which is much higher, is the percentage of the couch potato view. So you get much more from people who've just joined the queue. So imagine you're joining the queue at Stanford. You're going, la, I'm off for lunch. Oh, bugger. I'm going to be here forever. Now that's the couch, and then in that situation, people think like the couch potato view. They see things as coming at them. And look how it changes as you get closer to the top of the queue. By the time you're about to get your sandwich, nearly everyone is all ego moving towards a future of limitless possibilities. They've remarkably shifted from one frame of reference to another frame of reference. It's the same question asked in the same way to people, and the answer you get differs depending on where you are in the queue. It's bizarre, isn't it? I think this is bizarre work. They did the same thing at the airport. And you know, people at airports have very different sorts of relations to space. Some of them are hanging around waiting for someone to get off a plane. Some of them are waiting to get on a plane. Some of them have just got off a plane. And what you find is that the answer that this question elicits varies depending on what people are doing. If they're picking someone up, it's about 50-50. If they're about to fly, there's a greater number of people have the ego-moving perspective. Not surprisingly, I'm about to go on my holidays. If you've been sitting on a plane for hours and you just got off and you're through customs, hooray world, then everyone's in an ego-moving perspective and they answer the question differently. Isn't that bizarre? I don't know if this is the right way to interpret this rather weird data, and it does hinge on the answer to a specific, very specific question. What it does illustrate, though, is it gives a powerful illustration of how we reason using metaphor. So that it seems from this that the way that people are engaged with space, with moving through space, and with their own agency, influences the way that they think about time. This is a use of metaphor, taking concepts developed in one well-grounded domain and transferring them wholesale to another domain. There's a whole branch of linguistics now called cognitive linguistics that studies the metaphorical structure of thought, how all our thought is really metaphorical. That is, we start off from concrete reasoning and we develop concepts that then find application in all kinds of situations which are at some remove from the present. So language here again is appearing as a means by which we escape from the prison of the here and now and from our sensory motor grounding in the world. You may recall the chimpanzee Shiba, who solved the problem of the unequal plate with treats, selecting the plate that had the smaller number of treats so that she ensured she got the greater number of treats, only through the use of symbols, through the use of labeling things. And that provided her with enough distance so that she could master the situation and free herself a little bit from the sensory motor embedding in the world. So there's a lot to be learned here, even though we're not solving the big problems. We use metaphors all the time, and spatial metaphors are not the only way that we think about time. Don't make that mistake either. So here's a bunch of words that we use about time. We say that we're spending time, we're wasting time, we're investing time, and we have that nice phrase, time is money. Underlying all these is a completely different set of metaphors about time as a resource, something which you can squander, which you can have a lot of, or you can have a little bit of. That's a very different way to reason about time. And when we're thinking about time, we're shifting. We're using one spatial metaphor, another spatial metaphor, a resource metaphor, and there's probably a dozen other metaphors that we use in thinking about time. So, you can do some science here, despite the puzzles that it throws up. What about your experience of the passing of time? A lot of people have come to the view that time doesn't always seem to pass at the same rate. I'm not sure what that means. What rate could time pass at 1 second per second? That's a tautology. You can't pass at 2 seconds per second. A rate means something per second. Nevertheless, our subjective experience is that sometimes things seem to go on forever, and sometimes, whoo, they just go. Imagine you're in a white room, stuck there for an hour, and there's nothing but a clock ahead of you, and at the end of it, you're going to get a big injection from the nurse. Tick. Tick. Time's going to go really, really slowly. You're going to be a clock watcher. Imagine that you're engaged in a relay race, and you're waiting, and you get the baton, and you run, and you give the baton over. You weren't thinking about time. It didn't seem to take any time at all. So an hour spent, for example, in a boring old class, that's unfair. An hour spent doing something boring often seems to take a long time, whereas when you're engrossed and engaged, things seem to go more quickly. And why is this? We don't have an answer to this, and as you can see, I'm tripping myself up with my own words because the mysteries are too deep. But we know that there's lots of avenues to explore here. We know, for example, that if we adopt the view of experience as being constructed from the senses, that we're sensitive to change, and the amount of change will somehow contribute to our sense of the passing of time. We know that if we're expending a lot of effort on something, we tend not to be aware of time passing. Likewise, if there's something which grabs our attention. Remember that white room I said, you're sitting there, there's nothing but a clock, there's nothing for you to focus on except the clock, and you're foreboding about what's going to happen in an hour's time. There's no thing to engross you, to engage you. Whereas when you are engaged, when there's a lot going on and you're paying attention, you're not as aware of the passage of time. Now, even though we don't have a good handle on this, that doesn't stop us asking a lot of questions. We can build up experimental frameworks that can start to tease these apart. And the science of the perception of time is quite well developed. There's a lot of it. Very little consensus. But we can make some interesting observations as usual. We can compare, for example, your experience of the temporal intervals communicated through visual stimuli with your communication of temporal intervals communicated through your ears, through hearing. We're going to do just a little experiment here. One more. I'm going to illustrate an illusion, but it's a temporal illusion, not a visual optical illusion. I'm going to play you two beeps, beep and beep. I'm going to ask you to remember how long that was. That's the empty interval. And then I'm going to play you another interval which is exactly the same length, spoiler alert. It's going to be a beep, but then there's going to be a lot more beeps in the middle and a final beep. Now I've already given the game away. The two are the same length. I made them. I know that for a fact. But I want you to figure out which one seems longer to you. So here's the first one. No, it's not. It's not that long. What's wrong with my setup? Okay, that's your standard. I'll give it to you again. Okay, now it's working. That's the empty interval. Here's the filled one. Now, who thought the empty interval was longer? Who thought the filled interval was longer? Most people go for the filled interval. In the last class, it was unanimous. Here it's 50-50. You never know. Most people find that the filled interval, the one with more going on, is longer, more change, than the one with less going on. I can't tell you you're right or wrong. Of course you're right if it seems longer. If one thing seems longer to you, that's the question we're asking. You can't be wrong in some respect. But there's been a lot of experiments done here to establish some norms, as it were, or develop some expectations. And what we find is that the amount of stuff going on influences how long something seems to take. So if we have a filled duration, so like a beep, would normally be perceived as being longer than just beep, beep. And if something happens in that time, so for example, if the sound got louder, so contrast beep with beep, the one with more change generally seems to last longer. And we can compare this across modalities. So instead of beeps, we could use flashes. We can compare the visual with the auditory modality. We can do all kinds of changes to these stimuli. We can make the beeps go up and go down. And it's an area of active exploration. I can't give you any take-home message from it, except to point out how extremely prescient Aristotle's observation was. Aristotle didn't have our framework for thinking about it. He didn't have modern physics and Newtonian physics to lean on. He didn't have the notion of psychology. He didn't have the experimental method. Aristotle observed that our awareness of the passage of time is crucially bound to our observation of change. And everything we've learned since then suggests he was right. Good man, Aristotle. Right. That's enough about time for now. We'll come back to time again, and rhythm in particular, in Tuesday's lecture. You know we've no lecture coming Thursday. I sent you an email about that. Now we're going to just look at a little bit of brain woo about thinking about space. And we're going to focus on a rather select population here. This is not about humans in general. This is about London taxi drivers. Now you get into a taxi in Dublin, and you ask to go somewhere, and you've got a 50-50 chance of the taxi driver knowing where you want to go, let alone how to get there. In London, they have rules about this kind of thing. You don't get your license until you pass a test, and it takes about 2 years of study to acquire this kind of deep knowledge of the layout and geography of London. It's called the knowledge. And you don't get a license unless you can demonstrate that. So that makes London taxi drivers an interesting population, because they're constantly engaged in spatial navigation tasks, and they have worked very, very hard to acquire an inner map, as it were. And this is just a little report of a study. Slightly problematic, I think, but there you go, aren't they all? This is about changes in a part of the brain as a function of the amount of time spent as a taxi driver. Now, this is a big study, and they came at this from many different ways. Here, for example, there's a taxi driver while his brain is being scanned, describing how to get from Grosvenor Square to Elephant and Castle. And this has all been done in his head. He doesn't have a map now. And he says, I'd leave that by Upper Grosvenor Street, turn left into Park Lane, I'd enter Hyde Park Corner, one-way system, turn second left into Constitution, blah, blah. I'm not going to go through the whole thing. It's really long and complicated, and it demonstrates a remarkable ability to navigate in the abstract. Right? And it only comes with a lot of experience. And what they did was they scanned the brains of these taxi drivers, and they found that one part of the brain, the hippocampus, looks differently depending on how long you'd been a taxi driver. So these dots are the individual measurements. The x-axis is the amount of time spent as a London taxi driver. So there are newbies over there on the left, and these are experienced taxi drivers over here on the right. And the y-axis is a measure of the density of neural connections in one part of the hippocampus. And although the evidence is slightly weak, there is a trend here such that the longer you've worked as a taxi driver, the greater the number of neural connections you have in the hippocampus. Who knew? I'm sure you all knew, right? Hippocampus is an interesting part of the brain. It's part of the cortex buried deep within the brain. It's hard to get at. That's a slice through it. The word in Latin means seahorse, and you can see it's kind of seahorse shaped there. And it's interesting to consider what we've learned from this study, given some of the caveats that we've expressed in this course. So we know that the hippocampus is crucially involved when animals or humans engage in a lot of spatial navigation. We can look at this in animals much easier than we can in humans. We find that the volume of the hippocampus is bigger in those animals that engage in spatial foraging, and bigger still in those animals who go around, collect a bunch of nuts, hide them somewhere, go asleep for a few months, and then get up and have to remember where they left all that stuff. Squirrels, bears. Furthermore, there's a seasonal variation in it. In those times in the year when they're running around most, navigating most, the hippocampus is slightly bigger. So what we seem to have established is that there's a tendency for the hippocampus in animals at least to undergo structural physical changes. It gets bigger in response to the kind of behavior that requires spatial memory. It looks like, you pump iron a lot, do this kind of thing with weights, and your muscle gets bigger. Well, you navigate a lot and your hippocampus gets bigger. But here's the caveat. I don't want you to go away thinking the hippocampus is the part of the brain that does spatial navigation. I've tried to instill a great deal of caution in you at the premature association of function with place. And the analogy we always use here is the spark plug in the car. The car doesn't drive without the spark plug. Put the spark plug in, the car drives. It doesn't mean that the driving is in the spark plug. We all get that, right? What are we to make of this data that suggests that spatial navigation is hugely changed? Well, spatial navigation induces changes, structural changes that we can measure in the hippocampus. Well, the hippocampus is really weird because we've got two different literatures about the hippocampus. One concerned with navigation and animals that we've just looked at. There's a whole other literature concerned with something called long-term memory. And the study of long-term memory, that is memory that you can reliably access years after the event, there's one patient there who's extremely important. You remember Phineas Gage when we were looking at brain trauma? Well, the patient known as HM had surgery in the 1950s. It was necessitated by a medical condition, but it ended up in removing the hippocampuses. HM only died a few years ago. And in all that time, from the 1950s till the noughties, that patient lived in a little bubble of the present. Could remember the last minute or two of immediate exchange, but was incapable of forming any new memories. All the only long-term memories this patient had were those that were formed before the surgery. So the hippocampus is involved in this business of laying down consolidating memories, establishing whatever is necessary to establish in order to have recall years later. That's kind of bizarre. So we've got this schizophrenic nature of the hippocampus. On the one hand, it has something to do with spatial navigation. On the other hand, it has something to do with remembering. Are those two different functions done by one place in the brain? Is the hippocampus contributing to two different kinds of activity in two different ways? Or is there something we don't understand about memory that's related to navigation? That's also possible. It's worth remembering at this stage that one trick used in oral cultures for reciting very long poems, for example, Homer's epics, were always recited from memory, and they're very, very, very long. And there was a trick used, which is to imagine yourself navigating your way around the house. You can recall your own house, so you associate the first part of the story with going in the door, next part of the story with being in the hall, next part of the story with being in the kitchen. So you have this hypothetical path, and that allows you, gives you the hooks to hang your memory on. So maybe, that's fanciful on my part, but maybe there's something that we don't understand about spatial navigation and about long-term memory here. Maybe those terms need consolidation rather than saying this is the part of the brain that does X. What we have clearly demonstrated, though, is that experience, what you do, modifies the actual structure of the brain. It is influenced by what you do. So that's kind of interesting. Okay, we're going to stop there, and we're going to pick up the story next Tuesday. No lecture on Thursday. We're going to be talking a bit more about time and space and rhythm and dancing parrots, and then we get on to the last topic, which is going to be consciousness.